Bugblow, who's going to talk about hardware protocols. Thank you.
I already did it good. Okay, thank you. Hello, welcome. I have had this presentation in the Netherlands before, so there might be in some Dutch. I'm Dutch, so expect Dutchisms. And yeah, Dutchisms. I'm Bugblow. I'm a hacker, nerd, geek. I'm a member of the most awesome hackerspace according to Hackaday, Hack42 in the Netherlands. And also I'm a member of the Feest, who are providing you with free beer in the fridges near the food area. And please drink the free beer, we want to refill it. So, what do? I have a lot of projects and I have a lot of other things I do, but for this talk, important thing is I connect weird things to computers. And then you ask, what are weird things? Nah, things you normally would not connect to the internet, and you shouldn't. Your door lock, access systems, our heating for the Hack42 building. It's connected to the internet, so it's operated over the internet, works very fine. Cameras, barcode scanners, coffee machines, printers, water cookers, payment terminals, snack machines, weave computers, where you make fabric, you can automate that. Some more weird things, yes, but I don't know the exhaustive list. This is a nice image from our Hack42 heating SCADA system. This is actually how it's public on the website. You have to enter a password to send some actions, and please don't hack it. We rely on it. Very safe, very secure. Do I do that all alone? No, of course not. I'm basically not good in anything, but I can do a lot. That means that I ask help from my fellow hackers, from colleagues at work, and yeah, as you can see, I don't understand how, I know a bit how a resistor works, but the condensator don't get me started, and yeah, power is very dangerous. But I managed till now to stay alive. So what I use for it, and I'm going to talk a little bit about everything that's here on the slide. Things like a multimeter, a scope, a logic analyzer, wireless sniffers, some wires, soldering iron, Google. Yes, Google is bad, but it's the best search engine that's still available. Gambling, and of course my laptop and other computers. So for you who don't know, that's a multimeter. It can measure volts, so that's how high the power is. It can measure amps, that's how much power goes through. It can measure ohms, that's how good the power goes through. And it has a beep. The beep is very important, because if you're measuring is this connected to that, you don't have to look at the display, but you hear it. Very annoying, but you hear it. They start from about nothing in price. So make sure you have one. They're handy and they can save your life also. When you accidentally don't ground your device, you can measure it. There you go. A scope. Scopes are difficult devices. They have a lot of functions, but what they basically do is they show a line of how the power is moving, or how the power is moving from high and low. It can do a lot more. It can save, you can subtract, add different voltages and different signals. They cost about 100 euros for a small one. They're very handy to carry around. You have big scopes. They're very good in measuring, but yeah, moving a complete building to your office to measure it is not sufficient always. And taking the front door and say, I'm going to measure this in your office, is also not always very accepted. A logic analyzer. A logic analyzer is a a very handy tool. It can log the changes between a high and a low voltage. And there's some very efficient software to look at the signals. I have an image from that later. Yeah, wires. Wires are basically copper. If you don't want to touch each other accidentally, they have isolation. And yeah, you can make them from old, bigger cables or things like that. And they come mainly in 3 varieties, and you want them all if you start doing something tinkering. A soldering iron doesn't need to be a big one. You have them as very small as USB connected. So they work on the power bank. And some are actually good. Internet, I don't have to tell you about it. Gambling. Gambling is when something is undocumented and you have to guess how the other person was thinking when programming. It's the easy way to break it, but it's sometimes also the easiest way to make it work. Even if you have the documentation, when it's a few thousand pages, you can just, let's guess, this works. And then maybe look it up in the documentation later. Now, a laptop can be a PC or something. I use Linux, but Mac also works, and yeah, it's basically all the software works on all the main platforms. Android phones mainly now can also connect to an oscilloscope and a logic analyzer, and so even your phone would do for a lot of things. So when you get a device and you don't have, or you want to connect it to something, there are a lot of possible connections. So network, serial, parallel, analog, or wireless.
Is this picture taken in Albania?
This picture is not taken in Albania. This is ripped from the internet. Yeah, as you ask a good question, I like that, you get the stroopwafel.
Thank you.
So feel free to ask good questions, you get a stroopwafel. So most network connections are IP, as also the developers from devices which are not meant to be openly connected are lazy. They mainly use IP. Mostly they use TCP, and encryption is optional. More on encryption later. And as it's mainly network connected, if it's mainly network connected, there's mostly software from the supplier available, which might not help you to do it what you want to do, but we come back on that later. If it's serial, there are 3 options. What I encounter in the field, it's RS-232. You know that as the serial. There's TTL. If you ever played with a Raspberry Pi and connected the wrong TTL to USB converter and you blew up your Raspberry Pi, you know the difference between 3.3 and 5 volts. And there's also RS-485. And that looks like serial when you start measuring it and when you connect it. And then when you try to send it back, it starts to behave strangely. It's basically a differential, which means that on one of the wires, you set the negative voltage and on the other one the positive. So together, if you add them together, it's 0. So you can do it over very long cables, as it's not distorted by any other signals. You have a full duplex and a half duplex variant, because standards are made for more standards. There's an XKCD on that. The logic analyzer might hate you because it goes to a negative voltage. And your oscilloscope, if you put it in default settings, it shows a 0 line and then it goes below the 0 line. That are a bit giveaways that that's happening. That you might look into that as a protocol if you encounter that. Then you have parallel. Parallel are multiple connections at the same time. If you see it, if it's not SCSI, it's mainly 8-bit wide and sometimes 4 bits in all the devices. It can be unidirectional, which means it's going only from one side to the other, or bidirectional and half and full duplex. It's basically a mess, but as this is very much more difficult to implement, it takes more wires, you wouldn't encounter this as much in the real world. Analog connections, you see it sometimes written, yeah, it's connected by an analog cable or something. What I mean is it's a pulse. Mostly it's isolated connection, so there's an optocoupler on the other end, or you can connect it with an optocoupler. And yeah, it's one signal per wire. And if you connect 2 wires, the door will open, for example, or the magnet will close. And so that's what you then see. And then we have Wireles. Wireles is what they all promises to solve every problem of a wire. So they just take the protocols of the wires and then add more complexity. You have Wi-Fi. That's just like network, only without a cable. You have Bluetooth. Most Bluetooth implementations are a serial connection over Bluetooth. There's Zigbee. It does exist, I heard. I haven't seen it in much other devices than light bulbs and some power meters. And then there's the older 433 and 868 megahertz. And you know that from the clickers for garage doors or your car, older cars, or the click-on, click-off light switches. For those, the last two, you can just buy a USB to that frequency board, and you can start sniffing and sending the same data. Then we have connectors. Connectors are bad because they are all standardized, and everyone who invents a device creates a new standard. I've seen them doing power over network cables, using serial ATA for just a serial connection, which is correctly and true, only why that connector? So never assume that, oh, it looks like a serial port on my computer, it might be serial. It's a dangerous assumption because sometimes they put 240 volts over those cables, which is very, very bad. If you encounter that, please try to change it because the connector and the wires are really not rated for such high voltages. About wires and power and cables, if you see thick cables in a device, it mainly means lots of power. If you see very thin cables, it mainly means low voltage. But measure it. If you don't measure it and assume, then yeah, you're gambling and it will break. If you have thick cables and high voltage and you touch it, you break. If you have thin wires and a low voltage and you touch it wrongly, equipment breaks. So be very careful not to touch devices if you don't know what's happening with your bare hands. Also, make sure you have a ground fault interrupter. Ground fault interrupters save lives. A lot, especially if you're opening machines and start working on wires, or if you, by accident, don't connect the ground wire. Or and yes, switching on and off the device is time-consuming. You can make a remote switch or buy a power switch with a remote, or make something to switch it off when you think, oh, I need to reconnect the power wires. Make sure it's off. If you have your amp or your multimeter in amp measuring mode and you connect it to a power voltage, you basically create a shortage and your fuse will interrupt and blow. And also, on those devices, there's always a little test switch on your circuit breakers. press them, test them, because they might get broken down over time, and then at the right moment they will not save your life. Yeah, sometimes you encounter connectors. This is a very specific power cable which has 2 male parts. I don't know who made it, but it ended up in our hackerspace, and it's really, really dangerous. Because on those pins you see, very handy sticking out, and you can lick them, there is 230 volts. There's also a warning behind the power socket, there's a chance of 230 volts. Yes, that's 2 male ends. I didn't make it, it ended up because somebody found it in a box of power cables at the event. Some Chinese laser cutters come with it. Thank you, thank you. So, connectors, yeah, you have the DB9, RE45, which is not RE45, but everybody calls it that way. Pin headers, IDC, Molex, and none, and I'll explain them in the next slide. A DB9 connector you all know as Serieel, and it's actually called DE9. Yeah, might be DS9, but DE9 is the standard. Everybody calls it DB9. Works, we know it as Serieel. It can contain any signal, and sometimes you might actually encounter RS-232. These connectors, you know them as the network, telephone, ISDN. They might contain network or telephone or ISDN, but I've seen them used for sorry, for all purposes. I've seen them to transport USB, which is a bad idea because it breaks. But they're actually barcode scanners where you plug in a special cable from this connector to USB. Video, yeah. It's where you have a coax to RG49 connector. Pin headers. Pin headers are these things. They are just sticking out. You have seen them on your badge. On your badge, they're in the female variety, where these in the picture are all in male. It's very easy to connect wires to them. You can just plug them on or stick them in. And it's mainly very unclear what they are for inside the device, because it has something like connector 1 written on it, and that's it. You also have them in IDC. Mainly used with flat cables. Those are pin headers with a little bit of plastic around them. It's also the same, it's easy with cables. It's mainly unclear what it is. However, sometimes you see written down things like JTAG or ISP or ICSP, and that means that it's the programming port. And that's very useful to start debugging. If you see these connectors, they're Molex. They mostly do power. They sometimes add a little bit of data to some pins, and sometimes they add a little bit of power to some data lines. Almost always there's power included. Those connectors are made for power. If you have your computer, they are in there to distribute power. So be aware that there can be a lot of amps and voltages behind them. I have seen those connectors used for very high voltages. They are not made for them, but yeah, people make them anyway. And also you have connectors with nothing. You see here I forgot to translate. Test points. If you have a PCB, you might have some of these little dots. Those are test points. They might be debug ports. You can measure them, where they go to on the chip, for example, look up the chip specification, and find out what they do. Sometimes it's written there, as in this case of the board, and you can easily solder wires to them, as they're just bare copper, exposed copper. So, for example, if you take a cheap Chinese router, crappy software thingy, it contains network and it has a wireless and a few megabytes of RAM. OpenWRT software is available, and it's software locked, so you cannot update your own firmware. Normally you have to exploit the device to do that. Or, as in this case, open it up, find out what's written on the internet. And as you can see, there are two very small test points here, RX and TX. And on the other side there's a ground, and you solder 3 wires to them. And if you solder 3 wires to them, very nice soldering work, then you can connect a USB to TTL board. USB to TTL boards are basically making a serial signal on 3.3 or 5 volts. And you need 3 wires to connect them. If you connect them, you can put a resistor in between the device and the TTL converter. Resistors save your device. They don't let so much power into your device that it starts smoking, and the magic smokes escape and your device doesn't work anymore. Never use the 5-volt supply on those things. It comes from USB from your computer via a crappy converter, and the device might not be willing to accept it. Most devices have their own power supply, use that. Connecting 3 wires, there are more connectors to it, but connecting 3 wires is enough. As it's serial and it has no knowledge of the other side receiving, if you start copy-pasting long strings of commands for it what to do, the buffer might be overwritten because you're sending via USB into the 64-byte buffer of your converter. And when the 64 bytes are up and there are 0 remaining, and it's still sending one of the earlier bytes, you start overwriting the other bytes you want to send. So don't type too fast. So if you then connect it, you can see it's talking over serial to your computer. And then you can just copy-paste what you found on the internet. And then you have a better device because it's running some open source Linux instead of some Chinese locked down older Linux without security patches. In this case of this device, there are exploits available on the internet, so if you encounter any of them in the wild and you want to upgrade them, it's possible. Only do that with devices you own. So for serial, if you have a serial port and you want to know how fast it's talking, you can measure it with your scope or your logic analyzer. But first with your scope, just find out how long the smallest bit is. So when it changes from 0 to 1 or from 1 to 0, how small the time is that it was low or high. And then type it into Wolfram Alpha. And then it tells you how fast it's about. And then at some point, I should have a pointer. Oh no, it's hidden. You see down there, it's telling me 10 kilobytes a second, which is very close to 9600, which is one of the standard serial speeds. If you have a logic analyzer, just connect it and let the software do the rest. Just click on auto discovery and auto Baudrate, and it tells you how fast it is and actually also what bytes are there.
Shouldn't you be careful when hooking up 0 to
If you
units? Could be a different ground potential or different signal level.
if you have a logic analyzer, then mainly the logic analyzer has a ground in, what you connect to the ground of the device, and you also connect then to the data pins of the device. And with the serial to USB dongle, it can have a different ground. Yeah, but You could use an ISB isolator, or you could use a laptop and not connect it to the power supply.
Yeah, that's a good one.
Because if you don't connect your... You did it for the stroopwafel, right?
Yeah, I love it.
No, if you connect... he is right. If you connect something to a power source, and then your computer also, and the computer has a different power source, there might be a different in the ground, in the zero. But if you don't connect your computer to a power source and use the battery, then the ground is the ground, whatever it is, because there's nothing else that's pulling it to the earth. So save your laptop, use your battery. So in bits per byte, if you do serial, it's 8. Most. Always. I've seen 7, 6, and 5, and I also have seen 9. And 9 is bad, because Linux cannot do natively 9 bits on serial. Their parity bits in serial, nobody uses them anymore. Just ignore them. It's basically it's 98, 600, 8, and nothing. It's an older concept that your serial cable should have some integrity. It's these days mainly built into the protocol where they do checksums. About the protocols, there are binary and text protocols. The texts are very easy readable because it's text. It's like mail servers where you can actually type hello and a domain name and you get it back. It also works on serial protocol. There are also binary protocols. They're way more logical. There's things like checksums built in, and there are start and end markers, and you can see if a sentence is correct. And with text, that's mainly not built in. Inside the ASCII table, on the very start of the ASCII table, there are some start of text, end of text, start, end of sentence defined. If you see a binary protocol, mainly those are used for separating a message or parts of the message. And also the checksum is always on the end, because it's easier to just send the data and then calculate what you sent outside, then pre-calculate what the checksum might be and start with that. So if you see some random bytes at the end and think, that's strange, yeah, that's your checksum. If it's serial and it's text, then just type help or a question mark or dump sniff between what it does. Yeah, as said, text is very easily readable, but there's really no standard in knowing what to send, because you have to exactly know what the other developer thought while typing. For Pulse devices, at Hack42 we have a Wooten burner, and we connected it to the building, but we're not always there, and we want to have it warm whenever we go there, or close it down when we don't need it to save the environment a bit. Burning wood is CO2 neutral and things like that, but we don't pay for it, but still we try to be nice. Pulse devices are very easy to measure and very easy to test. They can make sounds like a roaring motor, or you hear a relay click. There's almost never a line that gives you feedback that, oh yeah, I have opened this relay or something like that, because it's mainly all the technology what you encounter when you do this. There are things like timing. If you open a gate, then you just measure it and then open it 1.5 times that long, and then you know for sure it's open. And if you want to know it's closed, then you send close again for how long it takes. So then you have things like more modern Bluetooth. you know, maybe have seen car dongles to plug in, or other devices which, for example, dildos or so, that connect to your phone and then over the internet via an app. They're mostly serial to Bluetooth converters, because developers are lazy and serial to Bluetooth converters are very cheap. Sometimes they're not, but as Bluetooth devices these days, they all come with an app. And you can decompile the app, and then you can very easily learn from it. Mainly they're written in some form of Java or some web app format, and encryption on Bluetooth devices is hard, so nobody does it okay. So encryption is mostly hard keys coded somewhere in the software, or derived from the device MAC address or things like that. If you have vendor software like those APKs for Android or for Windows, .NET software is very nice, because it's very, very good decompilable with JetBrains.peak decompiler. And so you can see exactly how they calculate checksums, what key they use, what methods they have to verify, what commands they send, and if they compiled it in a nice way, you get all their symbol names, so you know what every variable means. For Android, you can download APK, extract it and decompile it. As it's Java, if it's decompiled, it's mainly without debugging symbols, but as I've encountered somewhere on the internet, sometimes they not only pack the compiled java.class files, but also the source.java files, which is very efficient, because then you don't have to decompile it. And iOS, it's mostly not needed, because vendors want to make their hardware work with all phones, and Android is the most used platform in the world. So I have never decompiled an iOS app till now. It was not needed to make something work. If you have vendor software and you want to decompile it, you can first ask their friendly, how's your protocol working and can I do that? And then they can say things like, sort of, you need to buy a license to have that functionality. Okay, you didn't want to tell me how the protocol works, so now I make reverse engineer it according to European law. So first ask nicely, then get rejected, and then you're okay to do whatever you want to do. If vendors build in encryption, almost none do it correct. They have an invented here syndrome. It's mostly not real encryption. They copy paste some stuff from Stack Exchange and put it in their code. Hard-coded keys, hard-coded initialization factors for AES and all that stuff. If that's not really working and you want to dump some more data, get an older Android version in your emulator. Most vendors try to make their software work with the older Androids, and the older Androids are way more open for you to debug and dump memory, and they don't have this modern encryption stuff so good built in, so it doesn't hurt you while debugging. For wireless tools, the 433.868 MHz, you can very easily sniff, replay it. You can use GNU Radio, which is awesome software, but you really need to study it. And you really need to have a study about the radios and FFTs and to understand what this software does. But there's other software where you can just press record and play and do a replay attack. It might work. If it works, you know what they're sending. If you encounter American software, hardware, they are on a different frequency. You have a question?
Yes, so the 433 megahertz standard, you can get some very cheap transmission receivers off eBay, and you can wire them straight into a Raspberry Pi serial board, and that is a very, very effective way for
Yes. Yeah, he gets stroopwafel. I'll repeat it for the stream. You can buy some very cheap 443 megahertz senders receivers, connect them to your Raspberry Pi wireless or your laptop serial or your laptop serial, and then dump the data and replay it. So you get a stroopwafel.
It's just much easier than playing with software-defined radios.
Yeah, but software-defined radios are way more entertaining than just some text. Because if you connect such a receiver, yeah, it's just another serial protocol. Same works with Bluetooth. If you can pair to it with a Bluetooth receiver and it ends up being a serial protocol, it's serial again. There are also some clone devices. So if you're really lazy and don't want to even watch to a computer screen, you just double click on AliExpress to write copy my car keys or my garage key device, and it does it. Then there are vendors who always want you to firmware update. Don't do that. If you want to have a device do something else, don't update their firmware, especially not if they know what you're doing, because mainly firmware updates means we're locking it down. So try to downgrade firmware with less security and more known exploits to make it do what you want. They have tools, you have to run them on Windows, and yeah, have Windows somewhere available in a virtual machine to be able to do that. Because I've tried a lot of firmware updates running on Wine in Linux or things like that. And sometimes it works, but mainly it's just a pain in the ass.
But when you enter and do that, you can also use the USB monitoring and Linux to monitor the USB communication after the end and make your own firmware update.
Yeah, that's correct. You can monitor, if you run Windows in the VM and do firmware updates, you can monitor the USB, what it's sending over USB with the virtual machine software, or you can sniff the wireless and then yeah, you can make your own firmware updater. Sometimes then it's handy to also reverse engineer the firmware updater when it's doing some encryption. You get a stroopwafel. So let's see how many slides I have left. 7. Firmware downgrades, yes, as I said, less encryption, more known update mechanisms or exploits. If you get firmware, you can try starting binwalk, extract them with DD under Linux, use strings and a hex editor, and to look at what is it a file system, then mount the file system or things like that, and try to build your own software. If you do some programming, basically use Python, use Arduino. Why? Is it your favorite language? A little bit. Is Arduino your favorite platform? No. But there's a lot available, and there's a lot of copy-paste code available for different devices to connect it. So you can start with it, and once you know exactly what you do, you can upgrade to some other hardware. Yeah, Arduinos are really cheap these days to replace. There's some trial and error, there's some fuzzing. For Python, as said, it's really easy, and you can just copy-paste from Stack Overflow. I'm lazy, and I said other people help me, even if they don't know that they're helping me. It's very nice of them. For Arduino, it's very good. The hardware is very known. There's a lot of people who already collected a lot of other sensors and did things wrong. So you can just copy-paste their code from Stack Overflow. If you go fuzzing, if you find logic in bytes, then, and you see the checksums, then you can make your own messages and you can start sending a strange message to the device. Sometimes this message means reset and clear all your memory and everything you know, and then there's no way to firmware update anymore, so always have a spare device. Don't retest your software on the spare device. Been there, done that. Sometimes they're error codes, but most developers don't write error handling. They just go, if it's an error, then everything fails. Because
A good way of resetting the firmware if you momentarily break it or something.
yeah, if you
Restart the power.
yeah, if you momentarily break it, but sometimes you completely break it when you're starting fuzzing, because there's some factory resets to we need a new programming header on it. So I've seen that. And sometimes you just try sending completely other commands, and then you see that it has also not only one communication mode, but also completely different protocol when you start sending all A's in the beginning, then start to switch to text or something like that. How do I start? Now, think of a new problem, just make one, ask for some help, then YOLO a little bit around, and never throw your files away. Because yeah, I had a dump of this protocol somewhere. Oh no, I cleaned up every day. No, don't have a clean desk policy on your work directory. So I hope everything is unclear now. Then I have my mission accomplished. Does anybody want to gain a stroopwafel with a decent question?
Anyone? Questions?
Comments are also, yeah. Then I gain more knowledge. Let's see if we reward that. Probably. Yes. Somebody has something.
Okay. I have a router which ran DDVRT.
Yes?
And instead of taking the old version of DDVRT tested for the device, I took a new version from the FTP server. And I bricked the device.
Ah, you're wondering how to unbrick it.
Yeah. But I brought this TTL to USB adapter.
Yes?
But sadly, I typed some wrong numbers when trying to connect. So now I need a JTAG to recover it.
Yeah, I didn't bring any hardware from the Netherlands to here to do this.
Yeah, okay.
But yeah. Yes, but as you see, you break the device if you do something wrong. Yes.
I really bricked it, yeah.
If somebody here has a JTAG program header.
Okay.
Okay.
Thank you.
Now you get a stroopwafel and he gets a stroopwafel.
Good. I love this stuff with positive reinforcement. It works on BornHack attendees, it works on kids, it works on dogs, it works on horses. It works on presenters as well. Yeah? Any more questions?
Yes.
Have you ever been able to set up a machine monsters of weird things that you have hacked and gained access to make your own automated everyday script paradise wonderland? Like the Russian guy who got, he scripted everything in his life.
Did I script and hack my way around my life? No, I'm too lazy to do that. Hack 42 kinda is if you open the space state, everything goes on. If you close it down, the pinball machine goes off, but not automatically on when you enter. The lights of the fridge turn off when you close it. So we automated a lot there to ease our life.
How would you analyze a 5 gigahertz wireless transmitter or transmission? I can't get a hold of the documentation for the communication.
How would I analyze that? I would basically take a more professional network device, which might contain network debugging ports or some better software. I wouldn't know which brand, but I would take something like that and then start analyzing what I did. Because the more professional hardware is mainly better tested, which means they have more test points and programming headers on their PCBs. They have firmware updates and things like. But 5 gigahertz is pretty fast, so it's more difficult. So you need to buy better hardware to do that.
Okay, thanks.
Good.
Anyone else?
Yeah. I'm coming with stroopwafels.
No? If that was the last of the questions.
That was the last one. I have stroopwafels left, but come to me afterwards and you get one.
Have you ever played about with using the VGA port on your laptop as an I2C debugging tool?
If I've ever used the VGA port on my laptop as a I2, no, because I have Arduinos and other stuff like logic analyzers, so I don't need to connect. And my laptop is modern, it has no VGA.
Well, let's give Baglo a big hand.
So, thank you very much. And see you around. I'll be here all week.